Hi, in this lecture video, I will do a quick introduction to the alcohol functional group and then we'll go over the nomenclature of the alcohols. So first, alcohol are basically compounds that consist of the hydroxy functional group. And as we name them, they have the endings end with the word OL in them. And alcohol are very common in nature. There's many compounds with various functions that have the hydroxy group in them. For an example, so we can see here are the vast variety of compounds with different function, anywhere from dopamine, a neurotransmitter, to cholesterol, as we have seen here, and also many other substances as well. So they're very common in nature. And alcohol can also be further designated as primary, secondary, or tertiary, depending on the number of alkyl groups that are attached to the alpha position. And the alpha position is basically the position that is connecting to the hydroxy group. So here in this case right here, these types of alcohol right here would then be designated as primary. And the reason why is because we have one alkyl group connecting to this alpha position right here. And this alcohol right here will then be classified as a secondary alcohol. And again, this is because there are two alkyl groups connecting to the alpha position. And this would then be a tertiary alcohol because of three alkyl groups connecting to the alpha position. So please keep that in mind. The alpha position is the position that directly connected to the hydroxy group. And on this far right side right here, we have a very special type of alcohol, and this is called phenol. Now this is an example of an aromatic alcohol because the benzene ring is aromatic, so we call this an aromatic alcohol. And now let's go over naming of alcohol. So naming alcohol is very much similar to naming of all other organic substances that we have seen before already. And so there are four discrete steps that we need to follow when we name alcohol. And we have seen already that this is how we will name alkane. If we know how to name alkane already, we can apply that same principle to now name the alcohol. And the four discrete steps are follow. First, name the parent. Then name the substituent, and then assign the local number, and then list all of the substituents alphabetically. And so here are the additional steps right here that we would modify from the naming of alkane to name the alcohol. So when naming the parent chain, we would then replace the E in the hydrocarbon in the alkane with the word OL to indicate the presence of a hydroxy group. Now, so we can call this a hydroxy group or a hydroxyl group. They both refer to the same thing. If we know how to name the alkane already, we should be able to basically take out the E in the alkane and replace that with the O. So what this is saying that as we name the alcohol, we have to include this two words right here, AN, along with it. So here pentane, and if we were to now have an alcohol with 5 carbon long, then this now become pentanol. So again, please note that we would then include this AN along with the parent chain, pent for 5, and with the ending OL. And as we choose the parent chain of the alcohol, then make sure we identify the longest chain that include the carbon connecting to the hydroxy group. So basically that alpha carbon right there. The parent chain need to contain that carbon. So for an example right here, in this case right here, the parent chain have to contain this carbon. So this carbon is directly connected to the hydroxyl group. And when numbering the parent chain of the alcohol, then make sure the hydroxyl group receive the lowest number possible, despite the presence of all the alkyl group or pi bonds. So basically, once we have identified the parent chain already, we start from whichever ends. And we have to start from whichever end that will then give our hydroxyl group the lowest number possible. So here in this case right here, when assigning the local number to this parent chain right here, so we can see here in this case right here, this would then be our parent chain. And now I have to contain this carbon in it. And we can either start numbering 1 from this side or 1 from this side. And the correct way would have the number 1 starting on the left side. Because if we were to do that, now our hydroxy group would be on the carbon number 2. Okay, so this is important right here. Make sure we start from whichever end to give our hydroxyl group the lowest number possible, despite the presence of alkyl substituent or pi bond. And the position of the hydroxyl group is then indicated by using a locate number. So here's for an example right here. If we were to have this alcohol, we need to indicate whether the hydroxy group exists on this parent chain, and that is done by using the locate number. So here in this case right here, this will be pentane 3-ol. And this 3 right here tells us that it is located on the carbon number 3 on the parent chain. And make sure this 3 right here go after the parent name. So in the newer IUPAC guideline, then this is something that we have to follow. In the older IUPAC guideline, this can also be named as 3-pentanol. So the 3 go out before the parent name. But the most recent IUPAC guideline basically dictate the other way, where now we have to put this 3 right here after the parent name and before the suffix name. And if there is a chirality center present in the molecule, then again we have to indicate its stereochemistry, and the stereochemistry is then put in front of the name. So for an example, when naming this molecule right here, then this is the alcohol, and this will be carbon number 1, and now on carbon number 2 we have a chiral center, and this chiral center right here is then R. So we can either do 2R or simply R. And we don't have to use the 2R because there's only one chiral center in this molecule. So therefore we know that this chiral center right here belongs to this carbon number 2 already. So putting all of these together, then we have 2-chloro, and now this 3 right here, this is called the phenol group. Followed by, okay, so by 1-propanol. Now, so this molecule right here, it seems that it is still being named using the older IUPAC guideline. So in the new IUPAC guideline, this would be named as follows. So the rest of this is correct, but now this would then be named as propane, followed by 1-ol. And sometimes we do not need this 1 right here, because when we don't indicate that 1, then it is assumed to be at the carbon number 1. But to make it clear, we need to include this 1 right here. So basically, this is an example of whether it does not matter whether we include the 1 or not. They imply the same thing. But for best practices, it will be good advice to include this number 1 right here. And in the guideline number 6, whenever we have a cyclic alcohol, then basically we want to start numbering the parent chain in such a way that the carbon connecting to the hydroxy group would get number 1. So for an example, this is when we name this molecule right here, we want to make sure this carbon right here get number 1. So this can be named as cyclopentanol or cyclopentane 1-ol. So the 1 can be included in here as well. And when this cyclohexane right here have substituent group on them, so again, make sure that this carbon, this alpha carbon right here, always get number 1, despite of the substituent. Because some student might think that, oh, maybe we should name this or number this as the carbon number 1 because we have more substituent that have the carbon number 1. But again, that is secondary. That is not as important as make sure the alpha carbon get number 1, or basically the lowest number possible. So this carbon right here should get number 1. And here in this case right here will then be R-3,3-dimethyl cyclopentanol. Or we can also put the 1-ol in here, cyclopentane 1-ol in between. And whenever we have an aromatic alcohol, please remember that aromatic alcohol are different compared to cyclohexanol. Okay, so aromatic alcohol is whenever we have a benzene ring connecting to a hydroxy group, and the aromatic alcohol are then named as phenol. And the carbons connected to the hydroxy group always get number 1. And depending on how many other substituents they connected to the aromatic alcohol or then phenol, then we number them based on their location of how far they are away from the carbon number 1. So here in this case right here, this can be named as 2-methylphenol. And this one right here, so this is because this is carbon get number 1, number 2, number 3, 4, 5, and 6. So here in this case, this would be carbon number 1, and this is carbon number 3. So this would be named as 3-methylphenol. And this one right here would then be number 1 here, and number 4 here. So this is 4-methylphenol. Whenever we have a 2-methylphenol, we can also name this as O-methylphenol. So this O right here stands for ortho. In the ortho position is basically the position number 2. And the meta is basically whenever we have a group that located on the carbon number 3. So this is called meta or simply M. So M here for meta. So this can be named as meta-methylphenol or M-methylphenol. And this 4-methylphenol right here can be named as P-methylphenol. And this P right here stands for para. So the location number 4 on the phenol gets equal para or P. And now let's try some of the example of naming alcohol to make sure we know how to do this. So here in this case right here, let's try number 1. And so in this case right here, to name this molecule, the first step is make sure we identify the parent chain. And we can see here in this case right here, the functional group of highest naming priority would then be our alcohol, right? And therefore we have to name this as an alcohol. And the parent chain have to contain this alpha carbon that is highlighted. And now starting from this alpha carbon, we go to the left and right or top to bottom to find the longest continuous carbon chain to set that as the parent chain. So here in this case, we'll be going to the left, and here in this case to the right. And at this point right here, we need to go up, right, to make sure we can get the longest continuous carbon chain. So highlighted would then be the parent chain of this molecule. And now we need to assign locate number to the parent chain. So in this case right here, we have to start number 1 from the left side. And the reason why is, again, by the time we get to the carbon, the alpha carbon, then I get number 3. Versus if we were to start number 1 here, then we can see that the alcohol or this carbon right here will have a higher number, and that is not preferred. So therefore, we have to start from the left side. So this is 4, 5, 6, 7, 8, and 9. And now here in this case right here, we have a 4,4 dichloro group. So this is called a 4,4 dichloro group. And now this group right here, number 6 right here, this is 6-ethyl group. And please note that the carbon number 6 actually have a chiral center on it, right? This is a chiral center. And here in this case right here, it is R. So basically, we know that this is 6R right here. And the carbon number 3 is also a chiral center as well. And in this case right here, it is also R as well. So we have a 3R as well. And now putting all of this together, the name of this molecule would then be as follows. 3R, so the stereochemistry go first, and 6R. In this example right here, we have to include the 3 and the 6 because this molecule have 2 chiral center. So it's important that we designate which one is R and which one is S, or by using their number. In this case, they are both R, so we have to use 3R and 6R. Followed by 4,4 dichloro. So the dichloro will be listed first before the ethyl, followed by 6-ethyl. And again, all substituents will be listed alphabetically. And so we do not distinguish between what types of substituent group that they are, but then they simply being named and arranged alphabetically. So followed by ethyl. And now the parent chain is, in this case, 9 carbon long, so therefore will be non-N, followed by 3R. And that's the name of this molecule.